Today's flipped lecture, number 26, is on the representative concentration pathways, also known as RCPs. Although all of these representative concentration pathways are based on modeling, you will not have to know any of the complicated math. RCPs are scenarios that describe different trajectories of greenhouse gas concentrations in the atmosphere. These scenarios are used by the Intergovernmental Panel on Climate Change, or the IPCC, to model and project future climate changes. The primary purpose of RCPs is to provide a range of possible climate futures based on varying levels of greenhouse gas emissions. By using these scenarios, scientists can better understand how different levels of emissions will impact the Earth's climate, helping policymakers and researchers develop strategies to mitigate and adapt to climate change. The IPCC originally developed 4 RCPs, each representing a different level of greenhouse gas emissions and their potential impact on climate. I do understand these numbers are funny, and that is why this is a math-heavy activity, but you don't have to actually know what each number means, just what their pathway means. RCP 2.6 is a very stringent mitigation scenario that aims to limit global warming to below 2 degrees Celsius. It requires significant reductions in greenhouse gas emissions. The second is the RCP 4.5. This is an intermediate stabilization scenario where emissions peak around 2040 and then decline. It represents a moderate level of mitigation efforts. RCP 6.0, another stabilization scenario, but with emissions peaking around 2080. This pathway involves more gradual mitigation efforts compared to the previous RCP 4.5. RCP 8.5 is a high greenhouse gas emission scenario where emissions continue to rise throughout the entire 21st century. It represents a future with minimal efforts to reduce emissions. Each of these RCPs provides a different perspective on how our actions today can shape the climate of tomorrow. Radiative forcing is a key concept in understanding climate change. It refers to the change in energy balanced in the Earth's atmosphere due to greenhouse gases. Essentially, it's the difference between the energy the Earth receives from the sun and the energy it radiates back into space. Each representative concentration pathways, or RCP, has a specific radiative forcing target for the year 2100. This target is measured in watts per square meter. For example, RCP 2.6 aims for a radiative forcing of 2.6 watts per square meter, which represents a very stringent mitigation scenario. On the other hand, RCP 8.5, which is a high greenhouse gas emission scenario, targets a radiative forcing of 8.5 watts per measured square meter. These targets help scientists model different climate futures based on varying levels of greenhouse gas emissions. Just to get into 2.6 a bit more, it is the most ambitious scenario, aiming to limit global warming to below 2 degrees Celsius, which above the original pre-industrial levels. This pathway requires significant and immediate reductions in greenhouse gas emissions. It involves a rapid transition to renewable energy sources, widespread adoption of energy efficient technologies, and substantial changes in land use to increase carbon sequestration. Achieving RCP 2.6 would require global cooperation and strong policy measures to reduce emissions drastically. RCP 4.5 is an intermediate stabilization scenario where greenhouse gas emissions peak around 2040 and then decline. This pathway assumes moderate mitigation efforts, including the adoption of cleaner energy technologies and improvements in energy efficiency. While not as stringent as RCP 2.6, RCP 4.5 still requires significant policy interventions and technological advancements to stabilize atmospheric greenhouse gas concentrations. And if we move on to RCP 6.0, this will have the emissions peaking later, around 2080. The pathway involves more gradual mitigation efforts compared to 4.5. It assumes that some measures are taken to reduce emissions, but not as aggressively. RCP 6.0 represents a future where moderate policy actions and technological changes are implemented to stabilize greenhouse gas concentrations by the end of the century. RCP 8.5 is what most would consider a high greenhouse gas emissions scenario. It has been referred to in the past as business as usual pathway. In this scenario, emissions continue to rise throughout the 21st century, leading to significant increases in atmospheric greenhouse gas concentrations. This particular RCP assumes minimal efforts to reduce emissions, resulting in severe climate impacts, including higher global temperatures, more extreme weather events, and substantial sea level rise. Your first question is, which RCP scenario represents a high greenhouse gas emissions pathway where emissions continue to rise throughout the 21st century? That would be D, RCP 8.5. The implications of the different RCPs are profound. Higher RCP values, such as RCP 8.5, leads to more severe climate impacts, including higher global temperatures, more frequent and intense heat waves, and greater sea level rise. These changes can have significant socioeconomic impacts affecting agriculture, water, resources, and human health, as demonstrated in the icon on your screen, the image on your screen, and also infrastructure. Understanding these implications can help policymakers and research develop strategies, again, to mitigate and adapt to climate change. In addition to the original RCPs, the IPCC has introduced extended concentration pathways to allow climate modeling through 2300. These extensions help scientists understand the long-term impacts of different emission scenarios. The IPCC's sixth assessment report also introduced new RCPs such as 1.9, 3.4, and 7 to provide a more comprehensive range of future scenarios, each of them based on the radiative factor. RCPs play a lot of crucial roles, and many users or people can use this information to be helpful. Of course, it plays a crucial role in climate policy and decision-making, which we will engage in today. They inform international climate agreements, such as the Paris Agreement, and guide national policies aiming at reducing greenhouse gas emissions. By providing a range of possible futures, again, RCPs help policymakers develop and implement effective mitigation and adaptation strategies. They can also highlight the importance of global cooperation and the need for immediate action to address climate change. Understanding and knowing RCPs is a valuable tool for climate modeling, and unfortunately, they come with inherent uncertainties. These uncertainties arise from the complexity of the climate system, the variability of future emissions, and the potential for unforeseen technological and societal changes that could benefit or challenge our future. Achieving low RCP targets, such as 2.6, requires overcoming significant challenges, including technological advances, policy implementation, and global cooperation. Despite these uncertainties, RCPs provide a critical framework for understanding and addressing climate change. Representative concentration pathways, RCPs, are essential tools as identified. They provide a range of possible climate futures, understanding different levels of greenhouse gas emissions. Using this knowledge, we have the ability to anticipate the potential impacts of climate change and develop strategies to mitigate and adapt to these changes. Continued research and policy efforts are crucial to achieving the goals set out in the lower RCP scenarios to ensure a sustainable future for our planet. What is the primary purpose of the representative concentration pathways? To provide a range of possible climate futures based on different levels of greenhouse gas emissions. See you in class.